fearless navigators of the cosmos, restless minds and hunters of cosmic truths. Welcome back to our Ideas Laboratory, the meeting point for everyone who dares to look at the sky and ask, what if? Have you ever caught yourself watching a starry night, feeling that deep peace that only the immensity of the universe can bring us? That feeling of smallness in the face of infinity, but also of connection with something great, something that transcends us. But what if I told you that behind that serene beauty, that blanket of seemingly still stars that twinkle like distant diamonds, there are invisible forces of an almost inconceivable magnitude, traveling silently through the void, like whispers of ancient cosmic events, veritable sleeping titans. Today, my friends, we are going to dive deep, very deep, into one of the most powerful and at the same time most elusive phenomena in the universe. Something that even invisible to our eyes carries the strength of 1,000 angry suns and travels through the interstellar void like a colossal ghost, a wave of destruction and paradoxically of creation. I'm talking about the interstellar shockwaves and a concept that sounds almost like science fiction, ripped from the pages of a space epic, but which has deep solid roots in modern astrophysics, a veritable tsunami of radiation. Have you ever imagined an invisible wall of pure energy, hundreds of light years in diameter, sweeping entire galaxies like a cosmic squeegee, capable of altering the fate of worlds, of lighting up new stars in clouds of compressed gas and extinguishing others with its lethal breath? A silent threat that could, who knows, at this very moment be sneaking through our own cosmic backyard like an invisible predator in the interstellar darkness, unknown and implacable. It's a thought that sends shivers down your spine, doesn't it? The simple idea that out there, in the cold, dark expanse between the stars, a void that is anything but empty, there are forces so outsized, so fundamentally different from anything we experience in our everyday lives, that they could, in theory, trigger catastrophic events right here on Earth, without us even realizing they were approaching until it was too late. Think about ancient stories, the myths of different cultures that speak of shooting stars as omens, or of celestial events comets, new stars appearing in the sky that heralded great changes, plagues, or the end of times. Were these reports simply a product of the human imagination, an attempt to make sense of the unknown, or distant echoes of an ancestral consciousness about the dynamic and sometimes violent nature of the cosmos? A collective memory of events that our ancestors witnessed and tried to interpret in the best possible way. But is this idea of a radiation tsunami just a cosmic nightmare? Fertile material for apocalyptic film scripts and space horror tales? Or is there a real and worrying scientific basis for this possibility? What are the real dangers that lurk in these invisible waves of energy and matter? And the question that really matters to us, inhabitants of this small and fragile blue planet, what would happen if one of these shockwaves, carrying with it a tsunami of radiation, actually crossed Earth's path? Get your imaginary deflector shields ready. Adjust your mental spacesuits, because today we're going to dissect this silent threat, explore the fascinating and terrifying science behind these cataclysmic events, and find out whether or not we should add this item to our already long list of cosmic worries. But before we face this cosmic storm of epic proportions, before we look the abyss in the eyes, I want to make that special invitation that is already a tradition here, a sacred ritual on our channel. If you have just tuned into our frequency, if this is your first time exploring the far reaches of the universe with us, if your curiosity is as vast as the cosmos itself and your thirst for knowledge is insatiable, then my friend, you are in the right place. Don't waste another nanosecond. Subscribe to the channel. Right now, activate the notification bell, the one that looks like a small pulsating quasar, so you don't miss any of our future intergalactic investigations, and join our incredible, growing, and increasingly curious crew of explorers. And for you, our faithful journey companions, our cosmic veterans who already know the path to the stars and are not afraid of the black holes of ignorance. That luminous light, that thumbs up that shines like a supernova, is our antimatter fuel. The energy that drives us to unveil ever deeper and more complex mysteries. And how about sharing this video with a friend who loves a good scientific riddle, especially one involving cosmic dangers, the fate of humanity, and perhaps a dash of existential dread? Spread the word, because today's investigation promises to be electrifying and perhaps a little disturbing. Excellent. With all safety protocols engaged and curiosity at its peak, let's begin our journey. To understand the magnitude of a radiation tsunami driven by an interstellar shockwave, we must first demystify these two concepts. What exactly is an interstellar shockwave? Well, imagine the sound of distant thunder following a flash of lightning. This sound is a shockwave propagating through the air, a sudden and violent change in pressure, temperature, and density. Now, amplify this idea to an astronomical scale, where lightning are violent events that our minds can barely process. In space, which contrary to what many people think is not a perfect vacuum, but rather filled with an extremely rarefied gas called the interstellar medium, a tenuous mixture composed primarily of hydrogen and helium atoms, with traces of heavier elements and tiny grains of dust. The average density of this medium is just 1 atom per cubic centimeter, a vacuum far better than any we can create in a laboratory on Earth. Even so, extraordinarily energetic events can create colossal disturbances in this diffuse medium. Think of supernova explosions, the final grand spectacle of massive stars, those at least 8 to 10 times the mass of our sun. When such a star runs out of nuclear fuel, its iron core collapses under its own gravity in a matter of seconds. Ricochets, and the outer layers are violently expelled into space at speeds that can reach a significant fraction of the speed of light, something like tens of thousands of kilometers per second. This ejected matter, a cloud of superheated plasma rich in newly synthesized elements, pushes the interstellar gas in front of it like a gigantic invisible cosmic piston, generating a shockwave that expands for centuries or millennia, sweeping and heating everything in its path. A stunning visual example of this is the Crab Nebula, the remnant of a supernova observed in the year 1554. Its glowing filaments are gas-heated and swept up by the shockwave, a cosmic painting of destruction and renewal as these events scatter the heavy elements essential to the formation of new planets and eventually life. Or consider the powerful stellar winds blown by extremely hot and luminous young stars such as O and B-type stars. These winds are continuous streams of charged particles that can carve gigantic bubbles in the interstellar medium called stellar wind bubbles, with their edges marked by shockwaves. Our own solar system is believed to reside partially within one of these structures, known as the local bubble, a region of hot low-density gas about 300 light years in diameter, likely formed by a series of supernovae that occurred a few million years ago. We still have violent gravitational interactions between colliding galaxies. When two galaxies merge, a majestic and slow process that takes hundreds of millions or even billions of years. The vast clouds of gas within them can be compressed, heated, and stirred, generating shockwaves on intergalactic scales. And we can't forget the jets of matter and energy expelled by supermassive black holes at the center of most galaxies. When these black holes are active, devouring large amounts of gas and dust, they can launch collimated jets of plasma that span millions of light years. These jets, traveling at relativistic speeds when colliding with intergalactic gas, create some of the largest and most energetic shockwaves in the universe, capable of influencing the evolution of entire galaxy clusters. These shockwaves are essentially supersonic compression fronts that travel through the interstellar medium, sweeping up, heating the gas to temperatures of millions of degrees Celsius hotter than the surface of the sun, and compressing the cosmic dust. They can span tens, hundreds, or even thousands of light years. They're like cosmic plows pushing and shaping matter between stars, and can even trigger the formation of new stars by compressing clouds of gas and dust. And this is where things start to get really interesting and potentially dangerous. When these shockwaves interact with the interstellar medium, they not only heat the gas, they are also incredibly efficient at accelerating subatomic particles, protons, electrons, and nuclei of heavier atoms to extraordinarily high energies through a complex process called first-order Fermi acceleration. Imagine these charged particles being repeatedly bounced back and forth across the shock front, gaining a boost of energy with each crossing. These particles are transformed into so-called cosmic rays, space travelers that constantly bombard the Earth, some of them with energies millions, even billions of times greater than those we can achieve in our largest particle accelerators. And it's not just that. The violent physical processes that occur at these shock fronts, such as the compression of interstellar magnetic fields, can generate a wide range of electromagnetic radiation, from low-frequency radio waves through visible light to deadly X-rays, and the even more energetic and penetrating gamma rays. Now, what would a radiation tsunami be? This term, although not strictly formal, vividly describes the idea of a wave of intense radiation and energetic particles that could sweep through a region of space. As a direct result of the passage of a powerful shock wave or an isolated cataclysmic event such as a gamma ray burst. Imagine this shock front advancing, and along with it, a true avalanche of high-energy radiation X and gamma rays and super-fast particles, cosmic rays. It is not a wave of water, but a wave of pure energy and exotic matter capable of interacting in drastic and often destructive ways with anything that crosses its path, including planets, their atmospheres, and any form of life. The sources of these radiation tsunamis are some of the most spectacular and violent in the universe. We have already mentioned supernovae. A supernova close enough tens or hundreds of light years away could bathe the solar system in an intense and prolonged stream of gamma rays, X-rays, and cosmic rays for months or even years. Another even more fearsome source are gamma ray bursts, or GRBs. These are the most luminous electromagnetic events to occur in the universe since the Big Bang, originated either by the cataclysmic death of extremely massive stars hypernova or by the merger of compact objects such as two neutron stars. A GRB can release more energy in a few seconds than our sun will release in its entire life of approximately 10 billion years. Fortunately, this colossal energy is often collimated into narrow beams. If one of these beams were pointed directly at Earth, even from a distance of thousands of light years, the consequences for our biosphere could be catastrophic. And we can't forget about magnetars, a special type of neutron star with unimaginably powerful magnetic fields, trillions of times stronger than Earth's. Occasionally, these magnetic fields rearrange themselves violently, releasing gigantic bursts of gamma and X-rays. Such an event occurring in our galactic neighborhood, say a few dozen light years away, would be cause for great concern. So we have these colossal shock waves and these possible radiation tsunamis. The burning question is what would happen if Earth were in the path of one of these silent threats. What would be the tangible effects on our planet, our technology, and ourselves? First, our atmosphere, our protective shield. An intense flux of high-energy gamma and X-rays upon reaching the upper layers would trigger a series of complex chemical reactions. Nitrogen and oxygen molecules would be broken down and ionized. A worrying consequence would be the significant destruction of the ozone layer. Ozone is crucial for absorbing most of the sun's harmful ultraviolet UV radiation. If this layer was severely damaged, the amount of UV radiation reaching the Earth's surface would increase dramatically. In humans, it would lead to an exponential increase in cases of skin cancer, cataracts, and a widespread suppression of the immune system. For plants, including agricultural crops and marine phytoplankton, excess UV could inhibit photosynthesis, reduce growth, cause mutations, and even death. A collapse in food production and the base of the food chain would be an ecological catastrophe of global proportions. Furthermore, the interaction of gamma rays with the atmosphere itself would produce large amounts of nitrogen dioxide (NO) and other nitrogen oxides. These compounds not only contribute to ozone depletion, but can also form a dense reddish-brown photochemical haze in the upper atmosphere. This haze would block some visible sunlight. This could lead to a phenomenon known as global dimming and a sudden cooling of the Earth's surface, a type of nuclear winter induced by a cosmic event, with drops in temperature that could last for years. The consequences for the global climate would be drastic, affecting rainfall patterns and radically altering the seasons, making agriculture impractical in many regions. What about cosmic rays? Their super-energized subatomic particles are another major concern. Although the Earth's magnetic field, our magnetosphere, deflects most low and medium energy cosmic rays, A very large increase in the flux, especially of very high energy particles, could overwhelm this protection. Cosmic rays penetrating the atmosphere collide with the nuclei of air atoms, creating a cascade of secondary particles, an extensive atmospheric shower, including muons and neutrons. Many of these muons are highly penetrating and can reach the Earth's surface. A significant increase in the dose of ionizing radiation at the surface would have direct biological consequences, increasing genetic mutation rates, increasing the risk of cancer and other health problems. Some scientists speculate that past mass extinction events, such as the Ordovician Silurian, could be linked to nearby supernovae. Now, let's think about our technological civilization. Satellites in orbit would be the first victims. A radiation tsunami could permanently damage its solar panels, fry its electronics, and disrupt global communications, navigation systems like GPS, weather forecasting, and Earth surveillance. Losing a significant part of our satellite fleet would throw us back to a pre-space era with a gigantic economic and social impact. On the surface, electrical grids are vulnerable to geomagnetically induced currents, GICs, caused by disturbances in the magnetosphere. These currents can overload and damage high-voltage transformers, leading to large-scale blackouts that could last weeks or months. Communication systems and electronics in general, from computers to medical devices, could be affected by radiation spikes or secondary electromagnetic pulses, EMPs. It would be a collapse of modern infrastructure. The term silent threat is appropriate because unlike an asteroid, the light from a supernova or the beam from a GRB travels at the speed of light. We would have no advance warning of electromagnetic radiation. We would see the explosion in the sky at the same time as its effects hit us. For the slightly slower cosmic rays, we could have days to years warning, but for a bombardment of invisible particles, the effects of which would only manifest themselves when interacting with our atmosphere and technology. It's a bleak scenario, but before panic sets in, it's crucial to put things into perspective. The vastness of space is, in many cases, our greatest ally. For a supernova or a GRB to pose an existential threat, they would need to occur uncomfortably close to supernova less than 50 light years away, or a GRB a few thousand light years away with its beam pointed at us. Astronomers constantly monitor the sky. Fortunately, there are no known candidates who pose an imminent danger. Betelgeuse, about 650 light years away, will be a magnificent spectacle, but not a lethal threat. The chance of a galactic GRB hitting us directly is very low. Shockwaves from more distant events would have their effects greatly attenuated. However, this does not mean we are completely immune. Less intense events could still cause disruption. Earth's geological history may hold clues. Radioactive isotopes like iron-60 from supernovae have been found in ocean sediments and lunar samples, with peak concentrations dating back millions of years, suggesting Earth was bathed in debris from nearby supernovae. Some studies correlate these events with smaller extinctions or climate change. The research continues. Although an apocalyptic radiation tsunami is low probability, the phenomena are real. Understanding them is crucial to assessing long-term risks. It's a reminder that Earth is not an isolated island. So what can we do? The answer is observe, learn, model, predict, and if necessary, prepare. Our space-based and ground-based telescopes are constantly scanning the skies, providing data to refine models. Satellites dedicated to studying the sun and Earth's space environment help us understand the effects of radiation and particles. We are learning to predict space weather more accurately, vital for protecting satellites and power grids from solar storms, a more common form of radiation tsunami. Research into radiation-resistant materials, more effective shielding, and resilient network architectures are important steps. Developing protocols to shut down sensitive systems in the event of an alert is also part of the strategy. In the distant future, a multi-planetary civilization could have early warning systems or refuges. For now, our best defense is knowledge. The more we understand the universe and its dangers, the better equipped we will be. And perhaps this understanding will bring us an even greater appreciation for the rarity and preciousness of our planet. The threat may be silent, but our curiosity and our search for answers are anything but. And so, explorers, our journey through shockwaves and radiation tsunamis comes to a climax. We have seen that these are not fantasies, but real consequences of cosmic physics. Supernovas, quasars, GRBs all can unleash waves of energy and particles capable of traveling vast distances, interacting with planets, with consequences ranging from celestial spectacles to challenges to life and technology. Earth is protected, and the immensity of space often dilutes these threats. A truly catastrophic event is statistically unlikely, but the possibility of smaller events causing significant disruption cannot be completely ruled out. This silent threat reminds us that we live in a dynamic universe, but also of the incredible resilience of life and our ability to investigate and understand. The universe is vast, mysterious, and yes, sometimes dangerous, but it is also our home, and exploring it is one of humanity's noblest adventures. So what did you think of this immersion into the hidden dangers of the cosmos? If your mind was expanded today, if you felt goosebumps contemplating the power of these cosmic waves, or if you simply love unlocking the universe's best-kept secrets, then show your support for our mission. Leave that stellar light, which shines brighter than a supernova in our hearts, and helps us continue bringing these in-depth investigations to you. And if by a fluke of quantum destiny you haven't subscribed to our channel yet, don't leave it until the next Ice Age. Click the subscribe button now, activate the bell with all notifications, and guarantee your place at the forefront of cosmic exploration. And of course, good knowledge is shared knowledge. Send this video to your friends, family, to that universe study group, and let's together increase our understanding of the place we live in. And speaking of increasing our understanding, our journey is far from over. There are so many mysteries out there, so many questions waiting to be answered. And in our next encounter, we will venture into territory that challenges the very fabric of reality, something that may be hidden right under our noses, or perhaps in dimensions we can barely conceive. Get ready, because the video that will appear on your screen soon will be one of those experiences that make you question everything. You won't want to miss out on this. Once again, thank you very much to each of you for your invaluable companionship on this exploration. It is always an indescribable joy to share this passion for the unknown with such curious and engaged minds. I hope you felt as amazed and inspired as I did. A cosmic hug full of high positive energy particles, and see you without fail on our next adventure. Until then,